Okay, guys, sorry that cut me off. So hopefully you realize that on potassium and bromine, we needed 1-to-1 ratio because our least common multiple between +1 and -1 is 1. So we would need 1 potassium and 1 bromine. So when we name this, we would name this potassium bromide. How'd you do? All right, just to review, all the above compounds have to end in "ide." Okay? We always end in "ide." I-D-E. Remember, we take the metal name and we add on the root of the non-metal and we add on the suffix IDE. Okay? So also remember that the sum of all charges when we add up all the ions has to be 0. Okay, remember compounds do not have a charge. Okay, so let's practice this. We're going to look on this and we're going to put sodium, potassium, barium, strontium, aluminum, and tin together with chlorine, chloride, iodide, sulfide, oxide, nitride, phosphide, and fluoride. Okay, so the very first thing we need to do is to determine our least common multiple between our ions. So let's do this group by group. Let's just go with sodium first. So sodium is a +1, chlorine is a -1. So what's our least common multiple between 1 and 1? Hopefully you said 1. So that means I need 1 of each. So 1 sodium and 1 chlorine. We would call that sodium chloride. That, in your neck of the woods, in your world, is called table salt. That is what you use as salt for your food. Sodium +1, iodide -1. We're going to need 1 of each, 1 on 1. Sodium, iodide. What about sulfur? Sulfide is -2. So +1 with a -2. Hopefully our least common multiple you came up with is 2. So how do I get +1 to equal +2? I need to multiply it by 2. So I'm going to need 2 sodiums for every 1 sulfur. Okay? +1 on sodium, -2 on oxygen. So I'm going to need 2 sodiums for every 1 oxygen. So Na2O, sodium oxide. Okay, +1 with a -3. Hopefully you came up with an LCM being 3, so I need 3 sodiums and 1 nitrogen. So Na3, 3 sodiums equals +3, and 1 nitrogen equals -3. Sodium +1, phosphide -3. So least common multiple is 3, so I'm going to need 3 sodiums and 1 phosphide. Na3, 1P, so sodium phosphide. Sodium, fluorine, -1, +1. So I'm going to need a 1-to-1 ratio. This is going to be sodium fluoride. Okay? Let's do the next one. Potassium is also a +1. Chlorine is a -1. So my least common multiple is 1. So I'm going to need 1 of each. So potassium and 1 chlorine, potassium chloride. Okay? Potassium is a +1. Iodide is a -1. So my least common multiple is 1. I will need 1 of each. Potassium iodide. Potassium is a +1. Sulfur is a -2. So my least common multiple will be a 2. So that means I'm going to need 2 potassiums and 1 sulfur. So K2S, potassium sulfide. Okay, oxygen is also a -2. So my least common multiple will be 2. So that means I need 2 potassiums and 1 oxygen, so potassium oxide. Okay, potassium positive 1, nitrogen negative 3. So my least common multiple here is 3. So to get positive 3, I need 3 potassiums, and I need 1 nitrogen. So K3N, potassium nitride. Okay, phosphorus is a negative 3, so to get a positive 3 with those potassiums, I'm going to need 3 potassiums. So K3P, potassium phosphide. Potassium being a positive 1, fluorine being a negative 1. 1 to 1 will be what I need, so potassium fluoride. Okay, how's it going so far? Okay, barium is a positive 2. Positive 2 now. Chloride is a negative 1. So I'm going to need 2 chlorides to get to a negative 2 to balance out barium's positive 2. So I'm going to need 1 barium and 2 chlorides. We're going to call that barium chloride. Okay, iodide is a negative 1. So same ratio here, 1 barium, positive 2, and 2 iodides to balance out that. So BaI2. And barium's positive 2, sulfur is a negative 2. So my least common multiple is still 2, but I only need 1 of each. 1 positive 2 and 1 negative 2 gives me 2. So 1 barium, 1 sulfur, barium sulfide. Same with oxygen. It is also a negative 2. So I'm going to have the same ratio here. 1 positive 2 plus 1 negative 2 gets me to 0. So barium oxide. Okay, this is where it gets kind of tricky. Barium is a positive 2. Nitrogen is a negative 3. So what's my least common multiple between 2 and 3? So let's write out our multiples of 2. We have 2, 4, 6, 8. Let's write out our multiples of 3. 3, 6, 9. We match at 6. Okay? So how many positive 2s do I need to get to positive 6? Hopefully you said 3. So I'm going to need 3 bariums. How many negative 3s for my nitrogens do I need to get to a negative 6? Negative 3 times 2 is negative 6. So I need 2 negative 3s. So I'm going to need 3 bariums, and I'm going to need 2 nitrogens or 2 nitrides. So we're going to call that barium nitride. Now notice phosphide is the same charge as the nitride. So do you think we're going to need the same ratio? Yeah, we will. So barium, 3 positive 2s and 2 negative 3s will get me 6s on both sides. So barium phosphide. And then fluorine is a negative 1. So can I do 2 negative 1s to get me to a negative 2? I sure can. So 1 barium and 2 fluorides, barium fluoride. Okay? I want you to take a minute and see if you can do strontium all by yourself. Okay, pause it and we'll check in. Okay, you ready to check? So strontium +2, chlorine -1. So my least common multiple here is going to be 2. So I need 1 strontium and 2 chlorines. Okay, +2, -1. My least common multiple is 2. So 1 strontium and 2 iodides. So strontium chloride and strontium iodide. Sulfur's -2, strontium's +2, so I just need 1 and 1. So strontium sulfide. Oxygen is also a -2, so that's going to balance 1 to 1. So strontium oxide. Nitrogen's a -3. So my least common multiple between 2 and 3 is 6. So to get to a positive 6, I'm going to need 3 strontiums and I'm going to need 2 nitrogens. So 3 strontiums, 2 nitrogens, strontium nitride. Same with phosphorus. To get to a 3 and a 6, a 3, a -3, and a +2 charge, I need a 6. So to get to 6, I'm going to need 3 strontiums and 2 phosphides. So strontium phosphide. And then fluoride is a -1. So my least common multiple is going to be 2. So I need 1 strontium to get to a +2, and I need 2 fluorines to get to a -2. So strontium fluoride. All right. Aluminum or aluminium, +3, -1. What's our least common multiple? 3. So to get to a +3, I need 1 aluminum and I need 3 chlorides. So aluminum chloride. Okay, same thing here. +3, -1. So I'm going to need 3 of those -1s. Aluminum iodide. Okay, +3, -2. 3 and 2, my least common multiple is going to be 6. You guessed it, 6. So to get to a +6, I'm going to need 2 aluminums. I'm going to need 3 sulfurs to get to a -6. So 2 aluminums and 3 sulfurs, aluminum sulfide. Same thing here with oxygen. It's a -2. So my least common multiple is going to be 6. So I'm going to need 2 aluminums and 3 oxygens. So aluminum oxide. Aluminum +3, nitrogen -3. So my least common multiple is 3. So I need 1 of each. Aluminum nitride. And phosphorus is the same thing. It is a -3. So I'm going to need 1 of each. So aluminum phosphide. And then fluorine is a -1. So to get to a -3, I'm going to need 3 fluorines. So 1 aluminum and 3 fluorines, aluminum fluoride. All right, tin, +4. So I'm going to need 4 -1s to get to a -4. So 1 tin and 4 chlorides. Sorry, 1 tin and 4 chlorides. So we'll call this tin 4 chloride. We'll get into the Roman numeral later, but this would be tin 4 chloride. We'll get into why we put a Roman numeral in later. All right, +4, -1. So same ratio, 1 to 4. So 1 tin and 4 iodides. All right, +4, -2. So I'm going to need 1 tin and 2 sulfurs. So tin 4 sulfide, 1 tin and 2 oxygens, tin 4 oxide. This gets kind of tricky. 4 and a 3. What's the least common multiple between 4 and 3? Did you say 12? You're right. So to get 12 on a +4, I'm going to need 3 tins. And to get 12 on a -3, I'm going to need 4 -3s. So tin, I'm going to need 3 of them. And the nitrogens, I'm going to need 4 of them. So tin 4 nitride. Same with the phosphorus. I'm going to have an LCM of 12. So I'm going to need 3 tins and 4 phosphides. So 3 tins and 4 phosphides. So that will be tin 4 phosphide. And then tin with fluorine. I'm going to need 1 tin and 4 fluorines. Tin 4 fluoride. Have a great day. We'll see you. Bye.